I'm Michael Neufeld. I'm Chair of Space History Division, and continuing the series on the Pioneers of Flight Gallery, which is directly over our heads, is reopened. I'm going to talk about Robert Goddard's Hoop Skirt rocket, which is part of the rocket section that's on this side so we'll go that way. This exhibit reinterprets many of these classic artifacts, aircraft that are in this gallery that have been there for a long time, but with a wholly new exhibit. It's really more than a refurbishment. It turned into a brand new exhibit. And and to make this exhibit consistent, we said it should be always about the 20s and the 30s, about this pioneering age of exploring new realms in aviation. And also, as we argued in space history a long time ago, it should have a section on rocketry, because although aviation was much further advanced in the 1920s and 30s than rocketry was, this was a pioneering age of rocket development, the very beginnings essentially of rocket development for ballistic missiles, military applications, and for space flight really began in the 1920s and 30s. So the rocketry section here starts over here with a discussion of the background in Europe, in which there were significant rocket pioneers, notably Hermann Oberth and Konstantin Tsiolkovsky. And we have the model of Konstantin Tsiolkovsky's idea of a space rocket that this is actually a model built in the Soviet Union, sort of representing his concepts for rocket development, which he actually pioneered all the way back in the late 19th century and first published in 1903 in Russian, although hardly anyone knew. But the most of this exhibit concentrates on Robert Goddard and the American Rocket Society, because that just happens to be the artifacts that we have, very strong collections in those two early rocket pioneers in the United States, and notably Robert Goddard. And of course, most of this audience is from the museum, knows something about Robert Goddard, but let me just sort of briefly, indicate that he was a physics professor at Clark University in Worcester, Massachusetts, through much of the career that he worked on rockets. It was a personal obsession of his about that rocket could be the way to get into space. And going all the way back to his student days around 1907, 1910, in 1909, he first realized that the rocket could work as a space propulsion system. And as obvious as that idea seems to us now, it was not obvious at the time, and a lot of different pioneers in different countries independently came to this idea roughly around the same time. And Robert Goddard was one of them. And he moved into a conventional career as a physics professor at Clark in the World War I time frame, but he really was still obsessed with the idea that he could pioneer the road to spaceflight by building a rocket and building rocket engines. And so he set out in that time frame to try to start building up an experimental program. In 1917, this Smithsonian institution gave him $5,000, which was worth a lot more money in World War I than it is now. You'd have to multiply that by a factor of about 20 to get the buying power that amounted to. And that started him on his road to experimentation. As I discussed in other talks, it led to him publishing. The Smithsonian basically forced him to publish something, and he published a little pamphlet called The Method of Reaching Extreme Altitudes. The cover is pictured here. Well, Smithsonian published it with a 1919 date on. It came out in January 1920 and created a big hoopla. Totally unexpected. It got into the newspapers. It made him famous overnight. It produced all kinds of exaggerated expectations that he was about to launch himself to the moon. And that kind of rumor that he was about to launch himself to the moon continued throughout the 1920s. It circulated around the world, appearing in the Soviet Union and Germany and other places. Meanwhile, he continued with his small-scale experiments. In 1926, he succeeded in launching a small liquid propellant rocket, and we have the replica downstairs. He modified that rocket into another rocket, which the actual rocket is downstairs from May 1926. And so he finally, with liquid propellant, his basic propellants were liquid oxygen and gasoline. He finally got something off the ground in the spring of 26. The hoop skirt rocket is kind of the next flyable rocket that he produced after that. And so this is going to be the main subject of what I talk about, this bizarre looking contraption called the hoop skirt rocket. Now I have a few pictures here. I didn't want to run tons of these off the color printer, but I have one set for me and 3 sets for everybody else. But I don't know if you can look at the front picture. This is what this artifact looked like after its once and only flight on December 26, 1928. It is a pile of debris. And one of my questions about this artifact is, how did it get to be this thing when it, was that thing after the end of its only flight? We don't actually know how this rocket was reconstructed or where it was reconstructed. We have very little information. I get the impression that the Goddard or Esther Goddard, his widow, because he died in 1945, later on when we received this in 1959, may have reconstructed it beforehand, or it's possible that the Smithsonian, when it was then the National Air Museum, and it was basically, we had a piece of Arts and Industries and the old tin shed aircraft building behind the castle, reconstructed it ourselves, so that this artifact we just don't know very much about. I'm going to have to confine myself to talking about how it works, but what its actual history of reconstruction, we're not even sure, in fact, what this thing looked like before it flew. The second picture in this set is a picture of the hoop skirt rocket, and this is a nickname that was applied at some point. We're not quite sure who applied it. Frank Winter, a longtime curator, Goddard expert, told me that it actually appears in some collection of films of Goddard flights that the Goddards assembled. So maybe it was Esther Goddard or even Robert Goddard himself who nicknamed it the hoop skirt. But this shows the configuration of the rocket as it was. This is an outtake from the picture here. And it doesn't look the same as this either. This upper hoop is missing. But on the other hand, this configuration in this picture was of an earlier version of the rocket. So what did it actually look like on the one time it flew on December 26, 28? Well, we're not really sure about that either. Did it really still have that upper hoop anymore? Is a question that I'm not really entirely sure about, because he tended to be a tinkerer. But the story on the origin of this rocket is that after he flew twice in the spring of 26, he then endured almost 3 years of frustration. He never got another rocket off the ground between April 26 and December 28. He, under Smithsonian pressure to produce results and demonstrate that he could actually create a rocket that would reach the upper atmosphere, he tried scaling up his rocket to a bigger size in 1927, and the thing kept failing to take off, failing to start, didn't go anywhere, and late in 27, he gave up trying to build this bigger rocket and went back to building a smaller rocket. And one of the more interesting things then, is that he went back in this rocket to putting the rocket nozzle at the top, which you'll see in the March 1926 replica downstairs, but not on the May 1926 actual rocket, in which he put the nozzle at the bottom. So he was experimenting with the rocket in different places. He was experimenting with different configurations. He went back to putting the rocket nozzle at the top in the hopes that it would be a more stable, and fly in a more stable configuration. There was a widespread belief in the rocket community early on that maybe if you put the nozzle at the top and it was pulling, the rocket would be more stable. This was not based on any good aerodynamic theory or understanding of this whatsoever. It was more or less kind of ad hoc without any really strong theoretical basis. And so he went back to this configuration. I find this whole contraption to be kind of amazing, and also, unfortunately, a sign that Goddard was a great tinkerer, but not a very good engineer, frankly. But at any rate, how this thing works on this rocket, the gasoline tank is over. You see the combustion chamber and the nozzle there in the middle of the top part of the rocket, and then right in the middle of that upper structure, you see a gasoline tank above it, and then Above it, under this cone at the nose, is a parachute container, which was, and you know, if this thing were ever to work properly, yeah, sure. Thank you. That's the gasoline tank, and then up here is a parachute container. And you know, this is just a cone, I suppose, for aerodynamics. He actually produced fairings to go over parts of this rocket to try to make it look more streamlined, but he never actually launched the rocket with the fairings on because he had this constant problem that his engines failed to produce enough thrust to lift the rocket off the ground. So he would start the rocket, it would start burning off propellants and start lightening itself, and if he was lucky, it'd burn off enough propellants that the thrust would build up to the point where there was more thrust than weight, and it would actually start to move. But repeatedly he had the experience that he started the rocket engine and it failed to lift. Now the other part of this rocket, this is strange about this thing, is these are the liquid oxygen tanks on the bottom. And below them are two things he called the alcohol stoves. In order to get, now liquid oxygen, which is a liquid that at 297 below Fahrenheit, tends to boil off and evaporate over time and create pressure in the tank anyway, but he wasn't creating enough, just a natural boil off of liquid oxygen wasn't creating enough pressure in the liquid oxygen tank to force the liquid oxygen all the way up to the engine. So he had these heaters underneath the liquid oxygen tank that would heat the liquid oxygen such that there would be more evaporation and more pressure buildup in the tank to force the liquid oxygen from the tank down there up to the top of the engine up there. And he has on the bottom of these things, is it both or is it just one? I think it may be just one. There's a wheel down here where he could remotely pull a cord to start the liquid oxygen flowing down into these burning stoves, and these alcohol stoves have an exhaust pipe here, so they actually have a little exhaust pipe. So it's really a crazy contraption. He has the two liquid oxygen tanks down there, and the liquid oxygen starts to be warmed up. It builds up pressure in the tank and forces the liquid oxygen up there. Gasoline flows down by gravity from above, and you know, that's how the thing is supposed to work. So, in fact, a specialist at the Garber facility has two diagrams of the kind of how this thing works, which he labeled, that you may find interesting as this thing circulates around. Well, he tried to launch this thing on September 29th, 1928, didn't get off the ground. He tried two or three more times in October, didn't get off the ground. I think one of the times, in fact, the liquid oxygen tank, the gasoline tank above the engine blew up. He had this problem sometimes that the flame would propagate backwards into the tank and the tank would go boom and explode, sending metal shards all over the place. It went up a couple of times and got caught in the tower. This was also very typical. And then finally, after modifying it over and over again, so again, you know, you have one picture of what the hoop skirt looked like at one time, which we think is early on in this evolution of this artifact. But what it actually looked like on December 26, 28 is a little hard to tell from the pictures of the thing sitting in the launch tower. He launched this thing in a tower. He had an old windmill tower that he'd modified into a launch tower, and the thing was supposed to go up the tower and fly. And finally, on December 26, 28, it did. It like so many of his early experiments, it got caught in the tower. It didn't come out straight. It came out sideways. It tilted over, went about 200 feet, about 60, I think it was about 60 or 80 feet in the air, and went about 200 feet laterally, crashed into the ground, and produced that pile of rubble that you see before you. So this represents a sort of Goddard's trying to scale his technology up, but not having a whole lot of money, not having a whole lot of help, since he was tended to be very secretive and wasn't really an engineering manager by vocation. He was still fooling around. This flight, however, because of that, was only the third time he launched, third time he successfully had a flight with a rocket was with this artifact. The fourth time he had a successful flight in July 29 with a somewhat different looking rocket with the engine at the bottom again. In fact, it created a new huge flap in the United States. because the thing crashed down, started a grass fire at his launching place, which was his Aunt Effie's farm in Worcester, Massachusetts. And this fire started a big newspaper headlines all over the place that Goddard moon rocket fails to make it to the moon and crashes in Massachusetts, and all kinds of wild rumors are circulating. He was forced to move his launching operation to an Army base in Massachusetts, Fort Devens, because of the flap created by that failed flight. But it had this incredible stroke of luck as a side effect, because about 3 months after the July 1929 flap over that launch, Charles Lindbergh, who's, of course, one of his planes is right behind us here, Tingma Sartok, read something in the newspaper about Goddard's rocket experiments, was fascinated by the idea, and he called Goddard up. Of course, it was still really, in spite of his fame, still just a physics professor at Clark University, and said, "I want to come up and talk to you about your rocket." And he went home and told his wife about it, and his wife said, "Oh yeah, and I had tea with the Queen of Romania." So like, sure, the world famous Charles Lindbergh just called you up and talked to you. And he said, no, it's true. And as a result of that, as we discuss in these labels, Goddard got money from the Guggenheim Foundation, and the Guggenheim Foundation, which was extensively involved in promoting aeronautics in these years, enabled him to move to Roswell, New Mexico in 1930 and scale his experiments up considerably. I think it was like $50,000. And at that time, when he was working on this, the Smithsonian was doling out money to him in small increments, like $500 at a time. And he was trying to kind of, in his own lab with a handful of assistants, was trying to cobble these things together based on these trickle of increments of money coming from the Smithsonian. So that allowed him to scale up his operation. If you go downstairs, you see the 1941 P-Series rocket, which looks a lot more like a rocket you think should look like, and is obviously a much more sophisticated vehicle than this thing is, produced 11 years earlier. However, I have to say at the end of it all, what's really important about Goddard is the way he inspired people to think about space travel through rocketry. As an engineer, he wasn't much of a success, because none of his rockets in Goddard, in Roswell, ever flew over about 9,000 feet or over a few hundred miles an hour. And they rarely worked properly, and they almost always crashed, and the parachute didn't come out. Occasionally the parachute came out. So he had a lot of experiments. He established world first, namely he was the first person to launch a liquid propellant rocket. But I think in the end his real importance is the way his 1919 work inspired the idea of rocketry and space travel around the world. Thanks.
Thank you for listening to this edition of Ask an Expert. A companion question and answer session for this lecture may also be available. For a schedule of upcoming Ask an Expert lectures at the museum, please visit www.nasm.si.edu.